In this video, I'm going to explain the derivatives, and this is the first lesson of the derivatives, beginning of the derivatives, introduction to derivatives. And we are going to start with the meaning of the derivative. Geometric meaning of the derivative is the slope. So derivative is slope of tangent line is going to be and how to find we have another definition here, slope. If you remember the slope in the analytic geometry, we were using the formula for the slope m, and m was representing the slope, and m was at the same time it was equal to tangent alpha. So m is equal to tangent alpha, and in trigonometry tangent alpha is opposite of alpha over adjacent of alpha. It's going to be okay. But here the important part, in derivative we don't know the angle. We are not going to use the angle. And here we have the tangent line t. Tangent line t is passing through the point A, and we are looking for the tangent of slope of tangent line at point A. How to find that one without using the angle or opposite of alpha, without using the alpha, how to find that one? Now we have the point B here, and when you choose one point B, if you draw a line between these two points, you have one right triangle between these 2 points here, and the opposite side, if this angle is alpha, this is opposite of alpha, and this is adjacent of alpha. Opposite alpha over adjacent of alpha, opposite of alpha over adjacent of alpha gives you the tangent of alpha, slope also at the same time. So without using the angle, we can find the slope. But we have another problem here, because this point has chosen here A and B. A line passing through A and B doesn't make the tangent line, because A and B, when you have A and B, the line is passing through 2 points from the graph, 2 points from the graph, and the tangent definition means a line that touches at 1 point to the graph, our graph. Okay, how to find this one? Now we are using approximation technique for this one, and this graph shows when we get closer to A. B was here, the line 3. Here this is the line, then B was here, and this is the line 2, and B move up, and this is the line 1, and when B becomes A, the line becomes, as you see here, that get closer, and that becomes tangent line. And what is the relation here, and how to calculate that one? If you ask, I explain again. If fx and x becomes a and fa, it means that the fx and fa, if they are same point, the result of this operation is going to be 0, and the result of this operation also is going to be 0, and this is 0 over 0 indeterminate form. And how to solve the indeterminate forms? We were using the indeterminate forms. For the indeterminate forms, we were using limit. If you replace by a, fa minus fa is equal to 0, and a minus a is equal to 0, and then it's going to be equal to 0 over 0 indeterminate form, and we are going to find one factor, common factor for these functions, and to solve the question. Only the way to solve 0 over 0 indeterminate forms, it's possible with limit. That's why we are going to use limit for solving the tangent line, the slope of tangent line. Okay, here this formula and this formula, they are similar formulas. It's like the point H is chosen very close point to A, and then it's going to be FA plus H minus FA over H, because when you replace X by A plus H, this is going to be FA plus H, and this is FA minus FA. Here it's written A plus H minus FA, and A plus H minus A, it's going to be equal to H, so which is denominator. So these are the similar formulas to find the limit, find the derivative. And here there is a geometric meaning, also explanation of the geometric meaning of the derivative. Here the formula, the previous formula for the derivative, this formula I'm talking about, the formula is FA plus H minus FA over H. Here the point is FA and H unit distance away from the A, so this is A plus H. That's why this is FA plus H, and as you see here, the distance between these 2 points, opposite sides I'm talking about, FA plus H minus FA, and the distance between these 2 points, if this is A plus H, this is going to be equal to H. So the form tangent of the angle, it's going to be FA plus H minus FA. Here also we have H, X plus H from the previous formula, X plus H minus Fx. This is delta of F, Fx plus H minus F, delta F over H distance. And this is the second line, and the point has chosen a different name, but this point, let's say this is A and B, and when A becomes B, when that's closer to B, as you see the orange one, the line orange one, which is orange one, becomes like red one, and when the distance H is equal to 0, the line becomes tangent line. As you see here, the line, the distance is H is getting closer to 0, 0, 0, 0, and when it's like that, when H is equal to 0, the line becomes tangent line. We are going to find the equation of the tangent line, and for the equation of the tangent line, I need to know the point. And I need to know the slope. So I need to think for the equation of the line. One point, which is y minus y1, is equal to m times x minus x1. This is the point, which is x1, y1, and the second one is slope, which is equal to m, point slope form of the equation of the line. Now I'm going to use equation of the line for finding the curve here, but I need the slope. If you remember, I said that for finding the slope, we are going to use the limit x tends to a, fx minus fa. Here we have the formula fx minus fa over x minus a formula. Here the a value, this value is the a value. A is equal to 1, x0 is equal to 1, or x1 is equal to 1. Here this value is our a value. Then the limit x tends to 1, fx minus f1 over x minus 1 is our question. What is fx and what is f1? Y is equal to fx, which is equal to x squared for the question, as you see here. So f1 is equal to 1 squared, which is equal to 1. So limit x tends to 1, x squared minus 1 over x minus 1. When you replace by 1, the answer is 0 over 0. This is the expected result because it should be indeterminate form. And for the indeterminate form, the solution method, limit x tends to 1, x minus 1 times to factorize the indeterminate form. It's going to be x squared minus 1 is going to be x minus 1 times x plus 1. The denominator I wrote again. And when you simplify these two, the answer is going to be equal to limit x tends to 1, x plus 1 is going to be, which is equal to 1 plus 1, that's equal to 2. So the slope m is equal to tangent of the tangent value at point 1 is going to be equal to 2. Then I'm going to find with respect to this one, I'm going to find the equation of the line. For finding the equation of the line, I'm going to use this formula. And here x1 is equal to 1, I said, and y1 is equal to 1. Here this is the y1 also it's going to be. So y1 is equal to 1 is going to be for this question. And here, when you're replacing the equation y minus y1 is equal to m times x minus x1, which is equal to y minus 1 is equal to m times m. We found that the slope of the line, we found it's equal to 2 times x minus 1 is going to be, then y is equal to y minus 1 is equal to 2x minus 2, and y minus 2x minus 1 plus 2 is going to be equal to 0, or minus 2x plus y plus 1 is equal to 0 is the equation of the tangent line passing through the point 1, 1, and with slope 2 it's going to be. In another word, I can write this one, or 2x minus y minus 1 is equal to 0. Also it can be. Here we have the similar question for this one. This time x0 value at the point minus 1 and minus 2. When you say the a value, it's going to be equal to minus 1. So a is equal to minus 1. And this is x1 and y1 at the same time, x1 value and y1 value for the equation of tangent line. We have to know that one. And limit x tends to a minus 1, fx minus f1 f minus 1 over x minus 1 is going to be, which is equal to f minus 1. Let's calculate what is it, because y is equal to fx, which is equal to x cubed minus 1, and f minus 1 is equal to minus 1 cube minus 1. It's going to be, and f minus 1 is equal to minus 1 minus 1. F minus 1 is equal to minus 2. It should be. Then it's going to be equal to limit x tends to minus 1 x cube minus 1 minus 2 over x plus 1. It must be here the f minus 1 value. Okay, then it's going to be equal to limit x tends to minus 1 x cube minus 1 plus 2 over x plus 1, and that's equal to limit x tends to minus 1 over x cube plus 1 over x plus 1. Here again I'm going to remind you about this one, a cube plus b cube, it's going to be equal to a plus b times a squared minus ab plus b squared. It's going to be, so here a cube plus b cube, because this is this one, it's going to be equal to cube of the expression, and it's going to be equal to limit x tends to minus 1 x plus 1 times x squared minus x plus 1, it's going to be over x plus 1, it must be. When you simplify x plus 1 and x plus 1, you have this expression, and that limit x tends to minus 1 square minus 1 plus 1 is going to be, which is equal to 1 plus 1 plus 1, and that's equal to 3. So at the point m is equal to 3 is going to be. Then if m is equal to 3, this is the second part. Now I found the slope, I found the derivative. At the second part, I'm going to find y is equal to y minus y1 is equal to m times x minus x1. Formula I'm going to use. And I know that m is equal to 3. And y minus y1, I said here, y minus 2 is equal to 3 times x minus 1 is going to be. And that's equal to y plus 2 is equal to 3 times x plus 1. Y plus 2 is equal to 3x plus 3, and y plus minus 3x, y minus 3x plus 2 minus 3 is going to be equal to 0. So y minus 3x minus 1 is equal to 0, or minus 3x minus y plus 1 is equal to 0 is the equation of the tangent line. Is going to be, I multiply by minus 1, and I got this result. Also let me inform you about that one.